So, okay, let's start. So we have a create table statement, and let me do a little bit further on the foreign keys. Okay, so first of all, when we do this option, when we do this, like a foreign key, attribute, reference, another attribute, primary key, right? When we do this, what happened is this is the restricted way, such that when we have something dependence on the reference relation, we do not allow the operation to happen. So this is kind of like too confusing, right? So let me explain that. So the previous page I showed is we specify here until here, right? So we say foreign key, say department number, reference department D number, that's all. Okay, without this red and the green color one. So without, so let me get rid of this temporarily. So if we have this line, let's see what happened. And then we'll see, we can have other options and to see what's going on. Okay, so let me give you an example to show what kind of thing we can do using foreign keys. Okay, so I'm going to show you, first of all, I have employee table here, and I have a department table. Okay, so employee has attributes like a social security number and the D number as one, and department has things like a D number, D name, the other attributes, right? And so say I give you a couple employee here, say 111 and D number 10. Okay, and so something like that, right? So we have a lot of other employee and other departments also. So this is just one, give you a couple things here. And so first of all, we know this is a foreign key reference to the department number, and the number is the primary key here, right? Okay, so let's see if we do this foreign key, we say this foreign key reference, you see this reference, this department table and reference to this primary key, right? So if we have this one specified, so what happened? So in one scenario, I'm going to get rid of the EE department. I'm going to get rid of this particular department. So what happened is when we have this, and I do have this employee works for the EE department, and in the case we allow this deletion to happen, then this one become a dangling reference, right? So this is a dangling reference. And remember, database, relational database, we don't allow dangling reference. So as a result, okay, if we have this kind of things with this foreign key reference, when we try to issue a delete statement to delete this employee, this EE department, then this request will be rejected. So in other words, this operation will not be done in the DBMS. Simply, even you issue delete employee, delete EE department, this will stay here and this one will not be a dangling reference. So in other words, this request this delete statement will be rejected and then nothing will be done on top of this result. We're still original one. So that's one way. If we don't specify any further things, that's what happened. So what happened if we want to have some control on what's going on? So for example, I can say on delete. That simply means when there's a delete operation, so this part is the event part, on delete is the event. and the set default is the action. So we want to specify when this event happened, what kind of action I want to perform. And this one, you want to pay a little bit more attention here. It's always confusing because this onDelete is not happening in the employee table. This onDelete happened in the department table because this is reference to the department table. So onDelete means I delete something in the department table. See, this is a foreign key, right? So when I delete something in the department table, the action is happen in the employee table itself. Okay, so they are not in the same table. So let's see what happened if we say onDelete set default. And what happened is if we issue, so I issue a delete statement to delete EE department and say this is deleted, right? So this is gone. And this one seems like a dangling reference. However, we have this action, right? So this action said set default. Then the default will be go back to here. So we have default. This is the case you have to have a default defined, otherwise it will not work. So that means we set this one to default number 1. So this one means we reflect a certain business logic. So for example, you design this for a customer and they said, whenever we remove any department, right, or cut a department, then everyone in that department going to go to the default department, that's number 1. Department number 1, that's actually CM. So all the employee move to CM, they are going to work for CM. So that's reflect this type of business logic. So as a programmer, you are responsible to write down this, but how you do this depends on the user requirements. If they say want to move to default, then that's the right operation to do. Okay, we also can do other operation on the action part. That's typically another one is cascade. Okay, so in the case of cascade, so when we delete this one, cascade means anything else, everything remove, I mean, everything reference to this, like this one, will be cascaded, deleted. So say if I do onDelete, cascade, then what happened is in the event of deleting this, this will be gone also. So this is reflect another type of business logic, that is when we cut a department, everyone needs to leave this company, okay? So department's gone, then all the employee must leave the company. So that's the business logic related to that. Okay, another thing is we can set to a no value. That's another, we can say onDelete. That's no. This is another another type of action we can do. And so in this case, let me get rid of this and get rid of this. So in this case, right? So we're going to delete EE. Right, delete this one, and I have a dangling reference how to handle it using this operation. So this one looks like that. Okay. However, be very careful about this. Sometimes we define an attribute not null. If that's the case, you cannot using this operation. Okay. And also, if something is a part of primary key, you also cannot use this. So now let me give you new share on this. Okay, so remember we talk about constraint relation at the end of this is end of relational model. So when we see delete, right? So I have this. So I can violate those constraints, what are the operation to do, and I set in SQL. So now you see in SQL exactly what we can do. Okay, so now we can see we can set no value, we can set default. We can set default, we also can cascade, right? So we can do that. So that's for delete. Let me clean this. Okay, perfect. And let me show the update. Okay, so not only we can do on delete, we also can on update. So on update, similarly, this is an event happened in this table, in the department table. And the cascade is the action that is performed in the employee table. Okay, so make sure you understand this clearly. Where's the event, or the event happening in which table, and the actions happening where. Okay, so we say on update cascade. So when we update something, you can think about delete old one and insert another one. But to make things easier, we actually allowed by SQL to do update directly, to specify what to do for update directly. That is, okay, so see, we update this one. And if we update something not a primary key, not a foreign key, then go ahead to update. So if update address, employee, no problem. But if anything related to primary key, foreign key, then possibly the update can cause issue. So for example, I'm going to change the number of EE into 15. Right, so I change the primary key of EE department. So what happened is, once we change this one, I'm going to have dangling reference here, right? And we cannot allow that. So that's why we can use this option to say on update cascade. So we can cascade this operation to here, to cascade, change this one to 15 correspondingly. So anything originally referenced to 12 here, since we change to 15, they all become 15, reference to 15. And that's cascade. And so for update operation, this is the one that most reasonable if we want to do control. And so the question here is, what happened if we don't control, right? Then that's actually go back to this, right? Go back to only this statement without this one. Then what happened? What happened is, when we try to update this one, this is the one get rejected. Still cannot update it directly. So what you can do is, so remember, this is always get rejected if you have the situation of delete or update. So what we can do is, we can go back to the employee table. Say, for example, I make this one temporarily reference to something like number 1, for example. And then you can go ahead to change this. And then after that, you can make this reference back to 15, things like that. And similar for delete, right? So if we don't specify on delete, set default, or on delete something, then when you delete something, say I'm going to delete CSC, then since I have dangling reference, I cannot do this. So DBMS will reject. So what can I do to do this? Then what you can do is, you can go to the dangling reference, possible dangling reference one. You can change this one. So for example, I can go ahead to delete everyone in computer science, means they need to leave, then I cut the department. Or I can go to computer science to change this, everyone go to default number 1, and then I can cut a department. Or I can make this one into a null value, means, you know, you don't need to work. Okay, you just go there, collect salary, and you don't work for anyone. Then you can cut this one. So that's another way. However, whenever we put a null value, make sure we do not restrict this in the previous definition already. So some of the attribute, like if it's a part of the parameter key, for example, cannot be a null value. Okay, so up to this point, you may think, all right, so in this case, we prefer to use this, right? So it seems like I prefer to use this. Actually, whether you use them or not, it solely depends on the user requirements. And also, not all the DBMS support exactly same syntax. Sometimes they have some variation on this. I'm going to show you MySQL in a few minutes, but just be aware of some of them, they don't support both. Sometimes they support with slightly different syntax, okay? And also you see very common, you have people just seeing this without this, without this. And that's not, you know, always a bad, that's all not always a word, you know, it's hard to say it's best to use or best not to use. Let's see the application requirements. So for example, okay, once we put this in, no matter which department get updated or deleted, the DBMS is going to follow exactly the same business logic to them. So for example, our business logic is whenever we delete a department, I'm going to move everyone to the CE department, move to default number 1, right? So that's a business logic. So once we specify like a set to default for delete, then every single department, whenever we have the situation, they are going to be set to default, right? So what happened if we have a slightly different business logic for different department, right? So for example, if I cut CSC department, I wanted them to move to department number 1, but if I cut EE department, I want to actually lay off everyone in EE department. Or if I have research department, if they, you know, they get cut, I want everyone to be not working for anything, just put a null value. And again, for null value, you need to see their original requirement, do they allow the situation happen or not? So that you can see according to different user requirements on different scenario, you actually can enforce this one, you should enforce them differently, right? But once you specify on delete set default, you set the same standard for different department. So in this case, it is good in just using one line without that. So you have the flexibility to handle the corresponding employee firstly, okay? According to whatever they say, for this department, you do what, the other department employee do what. And then you change the department. And also, as a designer, you always know the reference, right? So remember, we always have the original model. So that's basically this one. So we have a clear idea who is reference to what, right? So, so since we have that, it shouldn't be so difficult to do the corresponding things in the employee first before you modify the department. Okay, so it doesn't mean this is always bad. Okay, and of course, if you have the same business logic on all of them, it is easy to specify. In this way, you don't have to handle things manually within the employee and department. Okay. All right, and then one more thing is when you do your SQL assignment, right? So when you create table, this is the only thing I require to put in. This is optional, this is optional. So when I say optional means you put this in, you don't get more points, you don't get less point. But however, if you put things in, they must be correct. Okay, so if you use something different, for example, you say set default on delete, that's opposite order to do, then you have trouble creating your tables. Okay, so you put them in correctly. If you know how to do it correctly, you can, but you don't require to do this in the assignment. Okay. Right now, I'm going to show you the syntax in MySQL. So very similar actually compared to the standard. Okay, so let me using the same example to show. Okay, so remember, if we just specify this, right? So the operation will get rejected unless we handle the employee firstly, we smooth down handling possible download reference, then we'll go back to do the operation on that. So this is the one. And so when we say, let me do onD first. Okay, and the first option is restrict MySQL. This is the MySQL here. Okay, so I say on delete restrict. So what is restrict? So this very interesting here. So when I say on restrict, the same as you specify and stop here without the sentence. So in other words, these three words here is useless. You specify, you don't respect, whether you specify this or not specifying this, it give you exactly the same thing. So this is a restrict way already. And you put this one, it's same as you don't put this line there. Okay, and another thing we can do is cascade. This is the same as SQL standard on cascade. Means you delete something, the other one will get cascaded, deleted also. Okay, and we can do set no value also. Okay, so this is also the same. We do not have set default there. Okay, and also we can do no action. So what is no action? The no action is the same as restrict, and also the same as just specify here. So no action is the same as restrict, and the same as you only specify one until here without the rest. Okay, so that's four possible choice you can do. Okay, don't put all of them. You can only pick one of them from the given choice. Okay, so that's for on delete. Okay, so let's move on to update. Okay, and so on update, we have something similar. We can do restrict. Okay, so when we do restrict, it's the same as you specify until here, means they are useless, right? When you specify, same as restrict, because the default is the restrict way. And we can do, so if not this, we can do cascade. Now on update, seems cascade is most commonly used, most reasonable. Means the corresponding one will get cascadedly updated also. And another choice is we can do set null. When something updated, I don't want to direct dangling reference. I'd rather to see a null value. So that's another one. And make sure you know there's no restriction of null to null there. And the last one is no action. Okay, so no action, the same as restrict, the same as you specify only this sentence. Okay. So that's for the option. So if we go back, okay, so let me go back to this on delete, on update cascade, right? So we know on update cascade. So if I do on update set, or for example, so if I do this, then what happens is on updates updating this, right? So I change this to 15 and set null means originally reference to 12. This become dangling. So the dangling will be a null value here. Okay, all right, so that's for this constraint. Quite a lot of information. And further, we can also give name to constraints, right? And so for example, we can define primary key. We can give a name for it. And the foreign key will also give a constraint name. This is optional. You don't have to give a name, and many people don't. So the good thing about giving name is in the future, if you want to take particular constraints and to reference to that constraint, you can use the name, the table, and the name of the constraint to reference to it. So far, everything so let me go back to this is the relational model, right? So we talk about, we can do insert, delete, update, everything, and you see the SQL. We have actually cover all of them. Also, so also the schema-based constraint, right? All of them, you can see, you can use SQL to specify the domain, right? In integer, for example, key constraint, primary key constraint under the null value, null to null, right? And entity integrity constraint, primary key cannot be null, and referential integrity constraint, that's the foreign key. So all of them, they are in the create table statement in the data definition language. So that's why they call the schema based. You can define that when you define the schema using create table. So I try to link different lectures together so you know what's going on, right? All right, let me go back. Okay, so let's see this one. Okay, so let's see, another thing is a drop table statement. We know create table allow us to create, produce a new one. And if we don't need a table anymore, we can use drop table statement. And so when we use drop table statement, it will remove the definition. If we already have tuples in the table, then they are gone also. So the relation, once we drop it, no longer can be used for any query updates and any other command. So be careful you drop table. Say if you already have like 1,000 records in your table, once you drop the table, all the records are gone. Okay, so let's see the drop table command. what I recommended is using this command. So you see drop table, table name, that's all. Okay, you don't want to go anything further, but I'm going to talk about how to do things beyond this. So what you want to remember is you do drop table, table name, that's all. Okay, and so further, you can say drop table, table name, and you can say restrict, and you can say cascade. So let's see what is cascade. Cascade means all the constraints, like a foreign key, you have foreign key reference. And views, that's the next thing, like the last thing we will do in the SQL section. This is a virtual table. When they reference to the one you want to drop, then they will drop automatically from the schema. And this is the SQL definition. So when you use cascaded way, you want to check each vendor's user manual to see exactly what kind of things they cascadedly dropped, and to make sure you don't drop things by accident, don't cascade by accident. So that's one thing. Another thing is if you use different database system, they can have slightly different syntax on cascade. So I always suggest avoid to use this option in the drop table. Okay. Another way is restrict. Okay. This way is we can only drop the table if nothing reference to it. And that's actually the same as you put restrict or not, is the same as you put this one. So the first, so you do this is equals to you do this one. Means this keyword is useless. By default, like when you see drop table, table name, that is the restrict way already. So let's see if we have, say, I have an employee table here, right? And I have SSN, other attributes. I have dependent table. And we have ESSN and other attributes. And this is reference to that, right? This is a part of the primary key, and this is a foreign key reference to that. So remember this. So when we have the schema like this, and we have, see whatever tuples here. And so when we say drop table dependent, it means that's the restrict way by default, right? So when we do this, we want to see, do I have anything reference to dependent? Suppose in my database, I only have 2 tables. Okay, so my current database, I only have employee and dependent. The only reference is ESSN reference to that. That's all. In this case, since nothing reference to dependent, then this operation will be successful. Okay, on the other hand, if I do something different, okay, so go back, I still have 2 tables only. And now I issue a command. I want to say drop table. And then I want to drop table employee. And nothing else. Okay, so one more thing is a semicolon here. This means the end of SQL statement. Okay, so when the query processors see this, they know no matter how many you type before, they combine everything until this as one statement. So that's the end of one SQL statement, they will run it. And then you do another one, you do this, and they'll run the next one. Okay. And okay, let me go back to this. So we see drop table employee. In this case, I can see dependent is still reference to it, right? So dependent, this is reference to it. And think about, so don't just purely memorize the rule, think about what will happen. So if this is gone, dependent here will have dangling reference, right? So we have dangling reference, I'm referring to employee, but employee table is totally gone. So that will cause inconsistency. So we cannot allow dangling reference. So this operation in this case will be rejected. So the DBMS will not allow you to drop the table. And this one looks like something bad, right? I want to do something doesn't allow me. That's actually a good thing to enforce a constraint, because you can do this like by accident. When you have like a complicated schema, you drop something and you didn't realize, oh, I have something reference to it. So the DBMS reject that. You need to go back to see, oh, I know the dependent actually reference to that. So you have to go back to the business logic to handle dependent first. So what happened? You ask your customer, when you want to drop the employee, you don't want to keep employee information anymore. What do you want to do with the dependents? And they may say, I don't want to keep the dependent. Go ahead to remove them. Then what you need to do is go to the database, issue a drop table. So you issue a drop table dependent firstly, then you issue drop table employee. So this drop successfully, then this one can be dropped successfully. So you can see this is all under your control as a programmer, right? So you know the sequence, everything. So that way you'll be able to drop things correspondingly. All right. So let's see. So again, one more time using this in your assignment. Don't use this one. Okay. So now, interesting thing about this. Okay. So when we create table, right, we need to follow certain sequence. Right? So especially when you do your assignment, you will see in order to specify everything here together without using alter table. That's the next thing I want to mention. I want to talk about it later. So when we do create table statement, if you want to put a foreign key directly, you want to know the sequence, which one should be done firstly, right? So in this case, when I create table, I want to create employee firstly, then I can create a dependent to specify foreign key ESSN reference to the employee table. So this one, create table. So I see this. So I create employee first, then I create a dependent. And then when we drop table, we want to drop dependent first, then I want to drop employee afterwards. So they are actually in opposite order, right? So create table and drop table, they actually they should be in opposite order. And of course, sometimes two tables, they don't have reference. Then which one create first, second, which drop first, which drop second, doesn't matter. But when we have this kind of dependency for foreign key reference, we need to think about the order carefully. Okay, next one, alter table. So alter table allow us to add attribute to the existing table. So of course, if you say, okay, we don't change the schema very often, but we change the schema, right? So we can drop the older table, add a new table, create a table again with the whatever, like the new columns. But that can be a trouble if we have a lot of records in it already, right? You have to drop them, create them, and add all the new record in again, right? So that's too much work. So instead, we can use alter table to do that. And many cases we can add, and we can also remove a column. So we can specify a new attribute and say this is the one. We say alter table, table name, and we do add, and we have attribute name, and then we specify the type of it. So let me put this in here. Okay, so say employee has many attributes like address, other things, and the number. And now I'm going to add one attribute called job here. So that's a brand new one. Before I have this in, so think about before I have this in, I already have some, already have some record here, right? So now we are going to add a new one by using this statement. So drop, okay? And that's a brand new column. And we cannot have empty space here, right? So there must be something because I already have this before I have this. So what happened is automatically this one will be added. Makes sense, right? We have to have something. So we're using this. Since this new one added, we want to have this. And then you can always later, I will show you using update statement to change them to a reasonable one related to the existing one. But by default, they are added this way. So this is the one show we can add column. We also can alter table to drop column. So say address, I don't want the address anymore. So we simply say alter table, table name, drop, and that's the column name. And this is easy one. So that's basically we have the address. And so this means this whole thing is gone. So this whole column will be removed. So that's the drop column. We also can do alter table, table name. We can alter the default of a particular attribute. Okay, we can alter the default, and we also can set the default. We can drop the default. We can set the default. So they are both alter attribute and by drop default or set default. Okay. So that's what we have for alter table. So totally, so this particular one drop the address totally, and this is the one. Say for manage SSN, we original has a default. When we do this statement, the default will be gone. And in this case, we already, for the manager SSN, doesn't matter we have a default or not. We can set a default to give particular value for manager SSN. Yeah. Okay. So up to this point, we actually learned 3 data definition language, 3 part. That's the create table. Means we produce a new one. We can drop. We don't want them. We want to remove. And if we want to modify, we can use the alter table statement, right? So we have the 3 things here, and they allow us to change the schema. And we don't have any actual data there, so this is the schema part. And then we'll talk about how to put tuples in, right? Remove tuple in the next class. That's it.